Hello everyone. Today we will define the notion of image and preimage. It's like one of the fundamental concepts in mathematics, especially at the university level. What I'm about to say right now may not make any sense to you right now, but pretty much anything you do, any definitions you make in mathematics, like more than half of them involve preimage. Image also appears in some definitions, but preimage appears like almost everywhere. We say a function is continuous if the preimage of open set is open. A function is measurable if the preimage of measurable set is measurable, and many others. So it's a good idea to be fluent with images and preimages and how they interact with unions, intersections, and all other sorts of set operations, because it will help you in the long run. So let's start with the definition of image. So the setting is as follows. We have a function f that goes from a set x to set y. And we say, given any subset A of x, the preimage of A written this way, the image of A written this way is a subset of y. So this is a subset of, so it takes in subsets and gives you subsets. It doesn't take in elements and give you elements of the sets. It gives you subsets. So f of A is a subset of y. And how is it defined? It's defined as follows. It is precisely what you think it is. It's just f of all the elements in A. F of A such that A is in A. So an example, I will draw a picture. Suppose this is your set X, and this is your set Y. And say set X has 3 elements, and set Y also has 3 elements. We need to call this one, so this set, the set of first 2 elements, call that A. This is our A. And then say our function f is defined as follows. This one goes here. The second one also goes here. The third one goes here. So this is our function f. Then, let me change the color again. Actually, let's use red. So then, f of A is this element. But it's not element, it's a set of one element. So f of A is set with this one element. So that one element set, let's call it A. So this would be f of A. I'll call this guy little a. So that's your image. And what's a preimage, you might ask? A preimage is as follows. We start with a subset of y, and then say C is a subset of y. Then we define preimage of C, and this thing will be subset of x. And how is it defined? It's defined as all the elements in x. If you apply f to those elements, you land in C. It's defined to be, say, x in x, such that if you apply f of x, apply f to that element, you land in C. F of x is in C. So an example would be as follows. Suppose I have like 2 sets, a random function. A function doesn't have to be one-to-one, onto, drawing. It have to be one-to-one or onto, or injective or surjective in other terms. Okay, say we have something like this. It might be a good idea to give these names. I will just call it x, y, z, w, and I will call those a, b, c, d. C, D. So preimage, I'll call this function f, and this is our set x, and that's our set y. So preimage of, say, empty set, first of all, well, is all the elements in X that map into this empty set, but like everything in X maps into something. So that would be empty set itself. What is preimage of, say, this set with one element? Well, it's everything in X that maps to this one element. So that's A and B. How about preimage of Z? Say Z comma W. It's everything in X that maps into Z and W, but if you look at Z and W, like nothing maps to Z and W, so it's empty set again. What's preimage of, say, X comma Z? That would be everything in X that maps to this X and this Z. But then if you look at them, only A and B map to X and nothing maps to Z. So it will be A comma B. So this is how preimage works. Now, the definition is simple enough. What about some of the properties? So what I'm going to do right now is I'm going to give you, say, 7 or 8 questions. And it's like fill in the blanks kind of question. So what you have to do is you just have to fill in the blanks. And on the next video, if you are interested, if you are not interested, then you can just let in the comment section, just tell me you are not interested. Then I won't do anything. But if you are interested, then you can just tell me and I'll just post the solution on the next video. But these are very important properties anyway. So if you have two sets of A, so in everything that follows, A and B, these will be subset of the original set that you go on, so of X, and say C comma D, these will be subset of Y. So if we take union B, so what's the relationship between f of A union B and f of A union f of B? So in the middle, you need to fill in with either these two are the same, whether the first thing is the subset of the second thing, or the second thing is the subset of the first thing, or there's no relation. So there's that one. Another one, f of A intersection B. What about the intersection? How about the preimages? If you take preimage of the something in Y, union D, what about f of C, union f of D? And the preimage of C intersection D, f of C intersection, that should be preimage. Preimage of C intersection preimage of D. Like how do these relate with one another? Like are these two equal? So what happens if you take the set difference? So this means all the elements that are in A but not in B. So from A you just remove every element that are also in B, then you get A minus B or A take away B. So how does this relate with this? Take away f of B. And 6 inverse of, say, C take away D. How does that relate with this? Take away inverse D. And finally, so what happens if you apply both f and f inverse? So you start with something in X, you apply f to it, so you get the image, so you get a subset of Y, and then you take the preimage of that thing. If you do this, do you get something you started with, or do you get something bigger or smaller? And the same thing, you start with something in Y, and the question is different from 7, because now we are starting in Y. So now we can go back to X by doing the preimage, and then we go back to Y by applying the image. Now the question is this bigger than, smaller than, or equal to C? And if these are equal, try proving them. If one of these things is a subset of the other, try proving them, and also give a counterexample to say why they are not equal. So for example, say something is a subset of others. So for example, this may not be true. I'm just saying, if this is subset of that thing, and these are not necessarily equal, can you give me an example where the right-hand side contains more elements than something in the left-hand side? And if you are fluent with like these kind of operations and how to prove them, or just know them, then you will find higher mathematics much easier to work with. I will end the video here. I look forward to seeing you all on the next video. Bye for now.